last problem, we solved for a vector problem using a right triangle. Now, and actually it wasn't just the last video, it was a little bit, we started that one in the video previously, so it took a while because we of course had to go through some fundamentals about vectors, and so it was more than just right triangle math. But it turned out being right triangle math, you gotta know how to do right triangle math. Right triangle math is throughout the entire course, so you gotta get it, doggone if you don't get it. Get it. And I'll do more right triangle math in this video. Well, actually, no, not this video, the next one. But this video, we're going to do a problem where I don't have a right triangle. I have a triangle, but not a right triangle. No, those are hard. You wouldn't do that to us, would you? Oh, yeah, I would. This is my, oh, yeah, I would face. Absolutely. And so most of the time you have triangles which are not at right triangles, things working like this. Let's say you decide you want to get some apple pie. You're in the mood for apple pie, you don't have any, and you're in the middle of Iowa. All right, not a lot of apple pie in the middle of Iowa because it's Iowa. So you decide to get in your car, and you drive. You drive at an angle of 30 degrees. Now let's practice this. 30 degrees, if that's north, this is west. So that'd be 30 degrees, and this is west. So 30 degrees away from north, or away from west, or 30 degrees from west, or 30 degrees of west. So that's how I say it. I say of. 30 degrees of west. So we're 30 degrees away from that westerly direction. So that would be how we're driving. Let's say you drive 100 kilometers. And then you know you got to take a turn here, okay, to get to Joe's Diner, to get some of that apple pie, going to Joe's Diner. So you turn here, and you go in this direction. That's west, that's south. So you're traveling southwest-ish of some sort. So let's say you turn here, and I like to draw lines. I love lines. Lines help me visualize things. And I like to draw lines, coordinate system lines. See what I did there? I'll even do it over here. I like drawing in coordinate system lines. They're going to help us. Trust me, they're going to help. So you decide to drive in this direction for that far. And let's say that this is 20 degrees. That's actually, looks like I made up more than 20 degrees, but let's say it's 20 degrees. And you stop. You finally get to Joe's Diner after driving 40 kilometers. You drove 40 kilometers. So 40 kilometers in this direction, 20 degrees, blank of blank, 20 degrees south of west. This is west, 20 degrees away from that, toward the south of west. And you stop, you're done. Okay, here's a question. What's your displacement? How far are you away from where you started from home and made it to Joe's Diner? How far are you? That's displacement as the crow flies. So let's see if we can do this without screwing it up. So you end up here. Nice. The green line represents your displacement, how far you are from beginning to end. Figure it out. What is the answer for that vector? Remember, displacement's a vector. So we not only do we need the length in kilometers, but we're going to need the direction that we're traveling as well. This is not a right triangle. Now, some of you might say, well, I don't know, it kind of looks like a right triangle to me. It looks pretty right triangle-ish. You got to prove it. You got to use some geometry skills. And if you're not sure, if you don't remember your geometry skills, you have to go with the assumption that it's not a right triangle. Because right triangle math only works for, well, you guessed it, right triangles. If I don't have a right triangle, I have to use what's called the law of cosines, and then I'm going to use the law of sines. And those work for any triangle. They will work for right triangles, but they also work for non-right triangles. So you have to make the assumption that I don't have a right triangle if I don't have my sweet geometry skills that I remember back in the day. But you do, and I'm going to help you out. Let's see. Is this 90 degrees in here? Is it? Let's find out. The reason I like drawing coordinate systems, I like drawing dotted lines vertically and horizontally, is it helps me visualize what's happening. And one rule from geometry was that if you have parallel lines, and this line that I dotted in here for my x-axis and this one I dotted in here are parallel. If you have parallel lines and you have a bisector, a line, a straight line that goes and connects them both, it's a bisector. Then you have what's called alternate interior angles are equal. A bisector has alternate interior angles. This is 30 degrees. That means this is 30 degrees. alternate interiors. Got to remember some geometry to do this. Now, I'm going to show you a non-right triangle mathematical solution using what's called law of cosines and law of sines. You need some geometry to pull this off. There is another method, okay, that does not have to use as much geometry knowledge, and I'll do that in the next video. But for now, let's go through the law of cosines and sines to solve this non-right triangle. Well, maybe it is a right triangle. Maybe it is 90. All right, good point. Let's see. Is it 90 in there? All right, we know that x and y, or north, south, east, west, are 90 degrees from each other. So if that's 30, that's 60. Okay? This is 20. So if that's 20, that's 70. Now, last time I checked, in here now we have 70 and 60. That's 130. So that's not 90 degrees in there. We do not have a right triangle. Okay. This is 130 degrees. So I'm going to go ahead and erase this here and put 130 in here. And if you didn't see that, back it up, SpongeBob. Back it up, back it up, back it up, back it up. Pizza delivery episode, SpongeBob first season, excellent episode. Busted Crab Pizza is the pizza for you and me. Busted Crab. Sorry, I'll get back to it. SpongeBob movie coming out in August, third one. Nice, gonna go see it. Saw the other two in the movie theater. 130 degrees in here, not 90 degrees. So, in order to solve this green line, which I need because the displacement means I need that green line and I need an angle. I'm going to need the law of cosines because I don't have 90 degrees. Now, law of cosines, don't panic. It's an equation. You don't have to know how it's derived, where it came from. You just have to know that it's an equation. And if you can plug things into an equation and do the algebra, you'll be okay. And we'll go through that. Law of cosines look like this. C equals the square root of a squared plus b squared. Hey, that's the Pythagorean theorem. It is so far, but the law of cosines is used for non-right triangles, so it has what I call a Scooch factor. The Scooch factor for non-right triangles is minus 2ab cosine c. That is the law of cosines. So it starts out very much Pythagorean theorem, and then we have this little part back here because we're not at a right triangle. Now, if we are at a right triangle, this actually will work for a right triangle. This just cancels out to be nothing. This cancels out to be 0 if it's a right triangle. All right, and that's because the cosine of 90. Cosine of 90, we all know the cosine of 90 is 0. So, if it is a 90-degree triangle, this would just cancel out, leaving me with Pythagorean theorem, which is what I would use on a 90-degree triangle. But this is not. So that cosine C here is going to have 130 degrees in here. This is side C. The side C, the unknown side C, and here's how it works with triangles, that the side and corresponding angle are opposite one another. So angle C is 130, side C is unknown. Side C, angle C. Okay? Corresponding sides and angles are opposite each other. So let's plug the numbers in. This is just an equation. Plug the numbers in and do the math. So let's do it. C equals square root. All right. A squared. Doesn't make any difference who you call A and B. Just pick. I'll call A 40. So 40 squared plus 100 squared minus 2 times A, which I call 40, times B, times the cosine of 130. Okay, keep doing the math. You can tell a marker is dying when it starts to squeak. No, quick. Dying marker. Switch it up. Go green. No, let's not go green. Let's go. Well, maybe blue. Maybe I can stick it out with blue. All right, let's do it. Come on. C equals 1600 plus 10,000. Okay, don't forget to take square root. Minus, okay, 40 times 100 is 4,000, times 2 is 8,000. in the cosine of 130, calculator, cosine of 130 is negative. See that negative? It's really important that you do not ignore it. You need it. Negative 0.6428. Negative 0.6428. Come on, squeaky marker, hang in there. Why is it important? Because you have a negative here and you're subtracting. Subtracting a negative, you're going to end up adding this. Muy importante, grande. So that negative gets subtracted, you add this together. So let's go ahead and add all this up. So C equals, that's 10,000 and 16,000, 11,600. Okay, no. This is going to be added because we're subtracting the negative. Add 8,000 times 0.6428, 5,142. Again, don't forget to take the square root. C equals plus 11,600. I can function square root. 129.4. 129.4 kilometers. You said earlier I put everything into meters, and that's in kilometers. You did it wrong. It is true. We do have to put everything into meters if we're using a physics equation. If we have one of the big three, you got to be an MKS, meters, kilograms, seconds, yes. If you're using any physics equation, then we have to have the MKS. But this is a Pythagorean theorem. It's a mathematical thingy. We use it in physics, but it's not a, what would be, we would call a physics equation per se. So we do not have to put it in meters. You can put it in meters. If you want to put that in meters, go ahead. It'd be 129,400 meters. That's fine. Doesn't matter. But you can leave this in kilometers. Okay, are we done? Are we done? We're done, right? Oh, thank goodness. That didn't take too long. It wasn't too bad. No, it's a vector. Displacement is a vector, so it means I need an angle. Right now I have the magnitude. I have the numbered value, but I don't have the direction, so I need the angle. Remember, I took the rules off. Well, guidelines. Took the guidelines off. They were here. They're gone. Guideline 3 is you have to find the angle where the two tails meet. And let's check that out, where the two tails meet. The two tails, if I look back here, are right here. That's head to head, that's head to tail, here's tail to tail. You need this angle. Green Pokemon ball, you need that. You're going to have to find that to get the direction. And I'll show you why you need that in just a second. Just trust me, okay? That's what Sitting Bull said to George R. Custer, and it worked out just fine for Custer at the Battle of Little Bighorn, okay? Actually, it didn't work out very well. Never mind, strike that. But just trust me, you're going to need that angle where those two tails meet. So let's get it. How? I can't use sine, cosine, tangent function. Those are for right triangles, not a right triangle. What do I do now? Panic? Don't panic. What you're going to do now is use the law of sines. Oh, is that another hard equation? No. It's a proportion. Proportions are easy. Proportions are easy. You ready? 1 is to 5 as 2 is to blank. 10. Very good, Macy. Very good. Okay, see, that wasn't hard. That's what proportions are. Blump is blump is blump is a blump. Law of sines is a proportion. And here it is. Law of sines is you put a proportion with an angle and its corresponding side and compare it to another angle and its corresponding side within the triangle. There are 3 choices of which angles and corresponding sides you can do, because there are 3 sides and, of course, 3 angles in a triangle. So what I'm going to do is try to solve for angle Pokemon ball. So put the side 40 and the corresponding angle here, Pokemon ball, together on one of the fractions. Now you can put the side on the top or you can put the angle on the top. It doesn't matter. It doesn't make any difference. It's a proportion. As long as you're consistent, it doesn't matter. But it'll be a little quicker. I'll show you why in a second if you put the angle on top. So the law of sines says the sine of angle Pokemon ball is to, proportion, is to the corresponding side, which is 40. The side of the unknown angle that we need to find where the two tails meet is the 40 as the sine. Okay, we need to pick an angle and a side. Well, which angle and side do we know? We don't know that angle, and that would give me two unknowns, and that would be bad. I know that angle, though, 130. So the sine of 130, and that is to this side, which we just figured out. We just figured that out. 129.4. So sine of unknown is to 40, as the sine of 130 is to 129.4. Cross multiply and divide. We're going to cross multiply and divide. That's why I knew it was going to be easier if we put the angle on the top instead of putting the sides on the top, which you can do, but you'll just have to do another math step in order to switch things around. So angles on top if you're trying to find an angle. Sides on top if you want to find the side. I'll just make it a little easier. Let's do the math. Cross multiply and divide. Okay, sine of 130. I'm going to do that first. So sine 130 times 40. I'm going to cross multiply times 40. Okay, it gives me some product here. I'm going to divide by 129.4. Okay, I get the sine of this angle. By cross multiplying and dividing, I get the sine of Pokemon ball. Oops, didn't mean to do that. Okay, right there. Don't look at the ln. I hit the ln button. But you can see the math there. All right, and it comes out to be 0.2368. 0.2368. So the sine of Pokemon ball is 0.2368. That's the sine of that angle. It's not the angle. So you know what to do. Okay, I'm going to erase this. If you needed it for some reason, go back and rewind and make it some room. So that I need to get the inverse. Second function sine. Second function sine. So that's not the angle. That's the sine of the angle. Okay, so second function sine 0.2368. And if I hit that second function sine, put it in there, hit enter, I'll get the angle. 13.7 degrees. 13.7 degrees. This angle comes out to be 13.7 degrees. Remember earlier? No, actually, I didn't say that earlier. I got all my videos messed up. In the last video I did. This video, I didn't make a prediction. If I did, I would have said 13.7. Yeah, whatever. So this angle is 13.7. Oh, finally we're done. Finally, the answer is 129.4 kilometers, 13.9 degrees, 13.7 degrees, north of west. No, wrong. Why is it wrong? Because what we just figured out, check this out, be careful. We just figured out this right here is 13.7 degrees. We need to state the direction we're going. The direction we're going is right here. This is the way we're going. This is west. Okay, remember that's west. We need to know this right here. We need to know how many degrees north of west, or north from west, or north away from west we are. Can you see how we're going to get that? This whole thing here is 30. Okay, from west to the blue line is 30. From the blue line to the green line is 13.7. So from west to the green line, which is what I need to know what this is. So that is my direction angle. I'll subtract 30, and I'll subtract 13.7 from 30. So 30 minus 13.7 is 16.3 degrees. Bam. Bam. So how do I say this finally and get this video over? Under 20 minutes, we can do this. Okay, answer 100, my displacement, 129.4 kilometers. Displacement's a vector, so I also have to say 16.3, that's 16.3 right here. 16.3 degrees north of west. That is the answer. All right, that is how to solve a non-right triangle using law of cosines, law of sines. Some of you are going to like that, about half of you will, and some of you don't like it, and don't want to do it, and want another method. There are two other ways of doing it. One's graphical. We're not going to do that today. The other one is another mathematical solution. Stay tuned.